Okay, gentlemen, 2.5 linear and nonlinear relations. We are going to use our GDC in the later portion of this handout. But in the meantime, let's start off as usual by just getting off the ground with a question to get the math juices flowing and add some math skills to our tool belt here. So I'm going to write this question twice because there's really two ways of approaching this type of question. Some might say three ways, but we're going to highlight two of the most popular ways to do this. And really it depends on how your brain works, how you feel more comfortable, maybe even how you were taught. But there's one method is to look at the left side, and right away we notice it's a little more difficult, a little more complicated than the ones we've done in the past, but we have seen this before, right? We've got some distributive property. This looks like distributive property right here. And even this looks like distributive property because they are. And we have also in here, we have nested brackets. Okay, so what we're going to do is we're just going to deal with the nested brackets first. We'll write this part here, -2x, and then we're going to take our +3 and distribute it to the x and to the -7. So 3 times x is +3x. 3 times -7 is -21. Close the bracket, equal 3/5. Now we're going to follow BEDMAS, so we have to collect like terms within the brackets, and you see here we have x plus 3x, so that's really 4x minus 21 equal 3/5. Now we're going to distribute the 2 to the 4x and the -21, sorry, the -2 to the 4x and -21. We get -8x plus 42, because negative times negative is positive, equal 3/5. And now to slowly get the x by itself, the variable we're trying to solve for, we have to get it by itself. So we're going to bring that 42, the positive 42, over, and we'll be left with -8x equal 3/5 minus 42. Now, to subtract 42 from 3/5, of course, we need a common denominator. So we have 8x equal, and then we have 3/5. The common denominator is going to be 5, right? As you remember, the 42 has an invisible denominator of 1. What did we do to the 1 to become a 5? We multiplied by 5. So we're going to multiply the 42 times 5, and that comes out to 210. So now I have -8x equal 3/5 minus 210 over 5 is going to give us -207 over 5. And at this point, we can cross multiply that times that. And the 207, the -207 is going to multiply by the invisible denominator 1 on the 8x. So we're left with -40x, because 5 times the -8 is -40, equal -207 times 1, which is -207. Then we're going to divide both sides by -40, and we'll get x equal -207 divided by a -40 is going to be a positive 207 over 40. Okay. Now, another method you could do is multiplying both sides of this equation by the lowest common denominator. Well, this denominator is a 1, and the other denominator is a 5. So multiplying both sides by 5 would do the trick. So I would put a 5 here, right? And I would just basically multiply the 5 times the -2. And I actually stop there. We don't have to distribute it all the way through. And I want to explain why. So again, one method is to multiply both sides by the lowest common denominator, but it's actually the same thing as saying cross multiply. I can multiply the 3 times the 1 and the 5 times what? The 5 would multiply by the entire term. And the reason why I'm calling that a term is because if you think about it, the whole thing is really one ginormous term, right? I have -2 times everything in brackets, right? All this stuff in brackets here is all one giant term. So when you're cross multiplying, why don't I have to distribute the 5 to the -2 to the x to the 3 to the x minus 7? And here I'll explain that. I probably said this in class before, but I'll give you an example. If you had 2 times 3 times 4, okay, the 3 is being multiplied by the 4, the 2 is being multiplied by 3, and technically the 2 is also being multiplied by the 4 because they're all being multiplied. And it really doesn't matter what order you multiply in, right? If I multiply 2 times 3, I get 6. What is 6 times 4? 24. If I multiplied the 3 times the 4 first, and then that's 12, multiplied by 2, 24. If I multiply the 2 times the 4 first, I get 8. And the 8 times the 3 would be 24. So again, it does not matter what order I multiply in. And because distributive property, so -2 is being multiplied by all that, right? That's distributive property is multiplication. And because that's the case, when I cross multiply the 5 times that entire numerator and the 3 times the invisible 1 denominator that's over here, then what I'm going to do is I'm really going to have a 5 times the entire numerator, which is -2, which is being multiplied, and I'm just going to copy. It's being multiplied by the entire numerator, and the 3 times the 1 is 3. See that? So if I just wrote the brackets here and multiplied both sides by 5, the 5 would cross reduce with this 5 here, and I would end up with the 3 anyways on the right hand side. Okay, erase that for a second. And then on the left hand side, I would just multiply a 5 times the -2, which would be -10, and that would be I would distribute a -10 to everybody, so, or to everything else. So that's what we're going to do anyways, right? Same thing as cross multiplying. I get -10 here times, and then I'm going to start doing distributive property. 3 times the x, 3x, and 3 times -7, -21, and it starts looking like what we did on the other side somewhat. Now we're going to collect like terms in the brackets. X plus 3x is really 4x, minus 21 equal 3, but now my fraction's gone. See that? No, I don't have to worry about getting a common denominator yet. -10 times 4x is -40x, and -10 times a -21 is positive 210. Now I bring the 210 to the other side, switch teams, change jerseys, and I get 3 minus 210, which is really -207, and divide both sides by -40. Negative divided by negative is positive, and so we get 207 over 40. So this method here lets us get rid of the fraction right off the bat. I personally like that one better, but if the other version, the method 1 that I did there, is better for you, go ahead and please, use whatever makes you more comfortable. The learning goal for today is to recognize a linear and a nonlinear relationship in a data set, okay, and to create a line of best fit with a pencil and paper and GDC. So we've already been talking about linear, nonlinear relations. What I'd like you to do is probably go to your textbook, and if you look at 2.5, I'm just going to try to pull it up here, and you can pause it on the screen if you'd like. But the definitions of linear relation, line of best fit, and curve of best fit are right there on page 77 and 78, and you can copy those onto your handout. Okay, so take a look there. You can pause the screen and write that out if you like. I'm going to go back to our Word document though instead. Okay, so you can copy those there. Well, let's take a look at them anyway, since I have them on the screen. A linear relationship is a relation between two variables that forms a straight line. And we've already done that with our GDC and some of the other videos. A line of best fit is a straight line that comes closest to the points on a scatter plot. And the reason why they say it comes closest is because the line of best fit goes right through the middle of the data. Right? When you're drawing a line of best fit, you want to have an equal number of dots above and below your line. That's your trend line. Obviously, if your line is not going through the dots or your statistics, and it's off course, well, then that's not really the trend line anymore, is it? A curve of best fit is a nonlinear relationship where if you graph your data, you'll notice that it kind of goes in a curve pattern. So a curve of best fit would go closest or right through the middle as much as possible of all those dots, just on a curve or not in a nonlinear way. Okay, so you can write those definitions there. And then here is exactly what we were just talking about, right? So this one here looks like we have more of a curve of best fit. So my line would go something like that. And we would say this one here is obviously non-linear. And then this trend line would be something like that. Maybe it's a little bit off course. Harder to do freehand, that's for sure, than with a ruler. And that would be linear. Okay, so there's a linear and a non-linear relationship. All right, now just by looking at this, how can I tell, excuse me, how can I tell just by looking at a set of coordinates like this, whether it's a linear or nonlinear relationship? Well, sometimes when the information is given in a graph, it makes life a little bit easier. So we have x coordinates and we have y coordinates here, right? So for example, and I wouldn't ask you to write this this way because this would be a waste of time. But I want you to think about it this way. I'm just writing these coordinates down, right? So -6, -4, -5, -2, -4 is my x, 0 is my y, -3 and +2, that type of thing. I'm not going to write them all out. I just want to see the trend. So if you take a look here, you're going to see the y. What happens to the x values? -6, -5, -4, -3. It's going up by 1 every time. And on the y values, we call these the first differences. The y values are going up by 2 every time. Because it goes up by 2 consistently, and if you look at the trend, you'll see -4, -2, 0, 2, 4, 6, 8, 10, 12, 14. It goes up by 2 consistently every time. And same with the x values, right? They go up by 1 every time. It's consistent. Okay, and because it's consistent, it's a linear relationship. It's like a staircase. You have the y, which controls up and down movement, and you've got the x, which controls left and right movement. So the x values are going 1, so it goes over 1, up 2, over 1, up 2. It's like a staircase, and that would be the slope. Okay, so that consistency means you have like a consistent staircase, right? You wouldn't want, if you had a staircase that went over 1 foot, up 3 feet, over half a foot, up 1 foot, you know, that it's different every time, then it's not really a linear relationship. It'd be a difficult staircase to cross. But if you're going over 1, up 2, over 1, up 2, over 1, up 2 every time, then you have a linear relationship. Okay. All right. We're going to use our GDC now to solve this. So I'll ask you to have that ready. I'm just going to pull mine up here and see if I can split the screen for you so we can see both things at the same time. All right. And I've got some information on my calculator that was already there. I don't want that anymore because I want to graph some new statistics. So because I see a line on my screen, and you might hit graph on your calculator and see that from work you've done previously, there's a couple of things. You can clear out your calculator if you like. Not necessary though. What you could do is, you know, you have a line, and the line is actually an equation. Okay, so we go to y equals here, the top left, and if you see an equation from work you've done before, well, we're not dealing with that anymore, so we want to clear that out. Otherwise, the calculator is going to want to graph that line as well next time you hit the graph button. So that's gone. But the statistics that we use to get that line are still there. So hit stat, and option 1 is edit. And I've got some information there that's from something else, right? Another homework question. So I want to get rid of that information. What do I use? My arrow keys. I go to the top, hit clear, and the down arrow, gone. Go to the right, go to the top, L2, clear, gone. Now I'm going to go back to list 1 and start entering this data, the 500, enter. Okay, and so you can go ahead and enter that as well. 1500, 17, that's not what I wanted. 1500, 1700. Okay, I'm actually going to pause the video quickly, and we'll touch base in 3 seconds when that's all entered. Okay, so all my data's entered now, and hopefully you just double check that your information lines up. List 1, double check your numbers. List 2, check your numbers, right? So you have 8.1 is my last number, 9.8, 11.2, 13.1. Perfect. Okay, so now all our information is entered correctly. If we don't have that lined up, it's going to graph improperly, or won't even graph. It'll say there's an error, dimension mismatch. So we have that entered there, and it's asking us to make a scatter plot on the and the question says make a scatter plot of the data. So if I want to make a scatter plot, I'm just going to hit graph because I've already entered the statistics. I'm going to triple check that my stat plot is on by hitting second function y equal. It is. Hit graph, and nothing there. You might remember the one thing you want to do here now is to select zoom and 9, zooming in on your stats. Remember that? So if I hit zoom 9, I see my data already lined up. Awesome. Then it says describe the relation and draw a line or a curve. This is very obviously a line of best fit. It's a linear relationship, just based on the trend of the dots there, you know, the data that we entered. So it is a negative slope. Okay, as the x values increase, as we go left to right, the y values are actually decreasing. Okay, so it's a linear relationship. And to draw the line of best fit, we're going to follow our pattern of stat, tab over to calc, and option 4 is linear regression or linreg. So hit option 4 on your calculator. Again, if you have the TI-83 calculator, what you want to do is at this point, if with that version, you're going to want to hit second function of the number 1 and then comma, right? That comma button above the number 7, and then second function of number 2. So L2 shows up on your screen, and then the comma button again. Okay, guys who have this, if you have this version, you're going to want to go to store reg, okay, and keep your cursor there. And then no matter what version you have, on the other version, once you've entered L1 comma L2 comma, and on this version, once you've gone down to the store reg, you're going to everyone's going to select the VARS button, the variables button. Select vars, tab over to the right to Y variables. Option 1 is function. That's what we want to select. So hit enter or the number 1. Then you want to select where you're going to store this. Everything's empty. So I'm just going to store it right where it is. I can hit 1 or enter again. And then you want to tab down to the word calculate. If you have this version, the other version, I believe you just hit enter. So we're going to hit on the word calculate, we're also going to hit enter, and our equation should pop up. What we've done there is we actually stored the equation so we can use it. And you'll see how we're going to use it in a second. If you don't do this whole store reg or store the linear regression or the equation for the, it's fancy schmancy math language for storing the equation for the line of best fit. Okay, there's an equation for that line. And if you hit graph, you're going to see that the lines show up. Okay. And if you hit the Y equal button, you'll see there's an equation there. If we didn't store the equation there, we would have the equation, and then once you leave that screen on your calculator, it would be gone. And when you hit graph again, you would not see that line. So here we're on the graph, and let's look at the next question. It says, use your line or curve of best fit to estimate the temperature at an altitude of 600 meters. Okay, if I'm estimating an altitude at 600, I'm just looking at my data in the Word document. 600 is somewhere in between the 500, obviously, and the 800 there. So it's interpolation, right? It's asking me to interpolate some information. It's between there. 600 wasn't a given point, but it's in there somewhere. How do we do this? So if you look at the trace button, see right there on your calculator, you have a trace button. Above it says calc. It's in blue, that's the second function. Every single button on your calculator has a second function. Otherwise, your calculator would be massive. So we're going to use that calc options by hitting second function and that button trace there. And it comes up, the calculate menu comes up, and we want to calculate a value. And we want to calculate a value when the altitude, again, looking at your Word document, when the altitude is 600. Remember, altitude is an X value and temperature is the Y value. The temperature depends on the altitude, right? So that's why we have the X, or list 1 are the data for altitude, and list 2 is the temperature information. So select option 1 for value by hitting enter or the number 1, and it says X equals. We want to find out what Y is going to equal when X equals what? 600. So type in 600 and hit enter on your calculator. And you're going to see that you get a Y value about 15.5 or 15.48. The question didn't say to round to anything, so we said estimate, so we could say about 15.5. That's a good estimate, 15.5 degrees Celsius. Okay, it's important there. Then it says for option D, it asks us to estimate the temperature at 2,500 meters. Okay, so let's go back to our calculate menu, second function of that button there, calculate. Option 1 is value, and we type in when X is 2,500. And if I hit the enter button, I get this message, error. Why is it why is it invalid? It just worked for the 600. And the reason is this, the calculator, so I'm going to hit option 1, by the way, to quit that. If you look at our graph again, hit the graph button, our window right now, when we entered our data, if you look at the X values in the Word document there, if you look at the X values, we only recorded values from 500 all the way up to 2100. And for Y values from 16.2 as the highest and 8.1 was the lowest. So we only have a certain range. Your calculator is only looking at about that range. And we're asking the calculator to please tell us some information when X is 2,500. And the calculator is saying, what? You only told me to put this in the window, and now you're asking me for information out there. We think the calculator is intuitive enough to say, hey, you know what, come on, that line's going to continue obviously off the screen, but it actually won't tell you that information. So how do we make it give us that information? There's a window button right here on your calculator next to the Y equal. Select the window button, and you see what the calculator does. We put the minimum value for altitude at 500 according to our data. But the calculator, when we did zoom 9 and zoomed in on our stats, the calculator gave us some buffer room, okay? So it didn't give you 500, it went to 340. And for the X maximum, see the X max has 2260. Okay, that's our X values go from about 500 to 2100. It went to 340, went back a little bit. And instead of 2100, it went a little further to 2260. And you'll notice on the Y values, it goes as low as 6, but we said 8.1 was our lowest. And the high is 17.577 if you look there on the calculator. And we said the highest was 16.2. So it gives a buffer on either end, but doesn't go anything more than that. So we need to extend our window on the X-axis to go at least to 2,500. So what we're going to do is tab down to X maximum because we need more X maximum value and make it 2,600. Let's just go beyond the 2,500 a little bit. We're going to do what the calculator does, give us a smidgen more room. So put 2,600 there, and then just hit graph. And your calculator, it kind of looks the same, but it actually includes the values up to 2,600. Now, if we hit second function trace or the calculate function, option 1, and we calculate a value in X as 2,500, you're going to notice it gives us the value 5.98. Now the question said estimate the temperature. So I'll say it's about 6 degrees Celsius when the altitude is 2,500 meters. Okay, hopefully that was helpful for you guys, and we'll see you next class. Take care.